function impairment and proposed study on epigenetic causality. So lung function impairment and disease. So lung function decline or impairment or LFI can start from early adulthood, and it is a significant risk factor for lung-related morbidity and subsequent mortality, such as COPD, lung cancer, or cardiovascular disease. DNA methylation is one of the most commonly studied epigenetic mechanism. DNA methylation is addition of a methyl group to the DNA structure, just like this. This is a methyl group, and it attaches to the DNA structure. And then we say this is a methylation. DNA methylation occurs primarily at the CpG site. A CpG site is a CG sequence of DNA where a C nucleotide is followed by a G nucleotide in the sequence from 5' to 3'. And DNA methylation reflects accumulated significant environmental impact and may stay relatively stable. So DNA methylation and lung function impairment. Studies have shown that DNA methylation in blood and certain CpGs is closely related to lung function impairment. For example, a study followed 169 twins for 11 years, and they found DNA methylation is associated with lung function impairment. And our team recently identified 3 genes mapping to 11 CpGs were on the biological pathway related to lung function development. So the goal of this study is to identify the CpGs with DNA methylation in blood at post-adolescent associated with lung function impairment in adulthood. So we will use genome scale DNA methylation at age 18 and to see if there is association between lung function impairment at age 26. So here, the first study or first step, we want to know if there is an association between DNA methylation and lung function. And the next step is that we want to know if DNA methylation is causally associated with the LFI, which means that DNA methylation causes the lung function impairment. So the study cohort, we used a birth cohort from Isle of Wight in United Kingdom. This is a birth cohort to study the natural history of asthma and allergy, and to identify potential environmental and genetic risk factors. In total, there were 1,533 newborn on IOW, and more than 98% of the cohort participants are Caucasians. And because of stillbirth, adoption, and refusal reasons, of the 1,536 newborn, there were only 1,456 are eligible to the follow-up of this study. So these 1,400 newborn were followed up at different ages, 1 to 4, 10, 18, and 26 years. In this study, we include 454 participants with lung function measured at age 18 and 26, and DNA methylation in blood at birth, 10 and 18 years. The identified CpGs will be further tested in a replication cohort called ALSPAC. We have a detailed information on this replication cohort later. So the method, we use FEV1, these 3 lung function parameters to estimate the change of lung function. FEV1, FVC, and the ratio of FEV1 divided by FVC. FEV1 is a parameter that to estimate the air that you expire or you push out for the first second after you taken a deep breath. So it is a measurement to estimate how if there is an obstruction in your airway. And the FVC is to estimate that the air that you exhale out after you take a deep breath. So it's more or less related to your lung development or your lung capacity. So here is how we estimate the change of lung function. And we applied a non-parametric clustering approach, k-means, to the changes to discover potential lung function impairment groups. And the DNA methylation in the whole blood was assessed using Illumina 450K and EPIC array. The R package combat was applied to DNA methylation to correct for batch and other factor effects. We used logistic regression to estimate the association between DNA methylation at a CpG site and the lung function impairment groups. And in those regressions, we adjusted for sex, SES, blood, BMI, smoking status, and asthma. This is the information about the ALSPAC-Replication cohort. So ALSPAC cohort is established in 1991 in UK, and this cohort include comparable phenotypic and DNA methylation in blood at multiple follow-up and genome scale SNPs. We will use similar approaches like cluster analysis and association assessment to this replication cohort to see if we can find similar findings compared to our IOW data set. This is the preliminary result from our IOW data set. This is FVC changes. We identified 3 clusters for the FVC change. The normal one, the dark group, is a normal group. And this light blue is the increased group. And this is a no change group, which means that these subjects can have some lung function issue because FVC is about your lung development. So as you getting older, but the development or lung capacity is not increasing as you getting older, then we think there might have some issue in the lung function. So this is the reference group, and we compare the cluster 2 to 1. We found 750 CpGs show significant interactions of DNA methylation and sex. And compared to cluster 3 to 1, we also found 612 CpGs showing significant interactions. So that means DNA methylation is associated with FVC change, and the effect is different by sex. And this is the cluster of FEV1 change. We also identified 3 clusters for the FEV1 change. This dark blue is increase, and this light blue is decrease, and this is the normal group, which is the reference one. We did not find any significant interaction between cluster 1 to 3 or the cluster 2 to 3. But when we compare the cluster 2 to 1, we found 4 CPGs showed significant interaction of DNA methylation and sex. So DNA methylation is also associated with FEV1 change, and the effect is different by sex. And then we picked up top 5 CPGs of the 750 and top 5 CPGs of the 612 to see if their gene is connecting to the lung function or lung function impairment or the COPD. So of the top 10 CPGs, there were 7 CPGs. There a gene is connecting to the lung function or COPD or lung function decline in the based on the literature. Discussion. We have found associations between DNA methylation at certain CPGs and lung function impairment in our preliminary analysis. However, association study does not establish the causality. A post-hoc Mendelian randomization looked up between DNA methylation and lung function using public dataset found that DNA methylation had a potential of causal association on lung function. To our knowledge, no studies have contributed to the causality of early age lung function impairment. And so our next question, our next proposed study is that, is there a causal association between DNA methylation and lung function impairment, which means that DNA methylation causes lung function impairment? In observational studies, usually we use an instrumental variable to help us to estimate the causal relationship. The instrumental variable, or IV, is a variable with these assumptions. First, the IV is associated with the exposure, but the IV is not associated with the confounders, and the IV influence the outcome only through the exposure. So here is an example so if we want to know if smoking is causally associated with lung function, and then we have a IV called cigarette tax. So based on the assumption of IV, cigarette tax is associated with smoking, but cigarette tax is not associated with other confounders, and the cigarette tax influences the lung function only through the smoking. So in this study design, we know that cigarette is only associated with smoking, and then smoking associated with lung function. And then we know smoking is causally associated with the lung function. So this is a concept of the instrumental variable. And many studies have used the Mendelian randomization, or MR, to incorporate with the IV concept in the epigenetic studies to estimate the causal association between exposure and outcome. In our case, this is the DNA methylation and the lung function impairment. And in the MR test, we use the genetic variant as a instrumental variable. And based on the IV assumptions, a genetic variant is associated with the DNA methylation, but the genetic variant is not associated with the confounders because it is randomly allocated at conception. And also, the third assumption is that a genetic variant influences the lung function impairment only through the DNA methylation. So because we know that the genetic variant is only affect the the lung function impairment through DNA methylation. So we know there is a causal association between DNA methylation and lung function impairment, just like the smoking and cigarette tax example. So the first step is using the MR test is to estimate the association between SNPs and DNA methylation. The association between DNA methylation and SNPs is called the methQTL. But in our case, we do not call it methQTL. Instead, we call it mSNP because we are not limited to the SNPs and CPGs on the same gene. So with this study designed and using the MR test, then we know we can estimate the causal association between DNA methylation and lung function impairment. But if we do not find any association between SNP and DNA methylation, then we propose a new method which include modifiable risk factors such as obesity or smoking to connect the SNPs and the DNA methylation so that we can still use the MR test to estimate the causal association between our exposure and outcome. So here is the concept of our proposed method. So we have IDVs, which is in between the SNPs and DNA methylation. And we first need to know the association between the SNPs and IDV. And in this association, we called a conditional mSNPs. So with this connection of IDV, then we want to know, and then we test if IDV is associated with the DNA methylation. And then we have association between SNPs and DNA methylation. Then we can use the MR test framework to test the causal association. But due to the implementation of the conditional mSNPs, the MR test is not a regular test, but involving an additional mediation assessment, which is like this. This from SNPs to DNA methylation is a mediation analysis. We first want to know if SNPs go to IDV and go to the DNA methylation. And then we have the association between the SNPs and DNA methylation. So we call this whole design extended MR test. A proposal with this focus has been submitted to NIH. Summary, in our preliminary analysis, we found associations between DNA methylation at certain CPG and lung function impairment. However, causality has never been established. We used regular and extended MR test to assess the causality. And an extended MR, which incorporating the mediation analysis into conventional MR, is the novel expansion of epidemiological method for causality inference. We are seeking NIH funding to continue this study. This study will benefit the causality assessment in other fields as well, such as cardiovascular disease and cancer studies. That's all my presentation today. Thank you.
Thank you. Are there any questions? It looks like there's just a few of us online. So what we'll do with our series is if you'll allow us, we'll go ahead and post a recording online so people can.
Sorry, Ramin, I noticed just to unmute myself when I was talking.
Oh, no worries.
Yeah, so I think I never received this link, but I asked Yushen for the link, so I'm not sure if I was supposed to participate or not. But anyway, I joined his talk anyway.
Okay, that's fine. That's fine. If that's the case, maybe we can rehost the session and sometime in the future and make sure the link gets out to everybody, because that's very disappointing if the link did not get out to everybody in time.
Right, I
You
don't
should
think
have.
I ever received the link
So
for
weird.
this. Yeah, but Yushen, I asked Yushen and he sent to me.
Okay. All right. I'm very sorry about that. That's an issue on our part. So if that's the case, then what we'll do is, if you're okay with us posting this online, we can go ahead and do that. And then we'll just reschedule for another session sometime later. Let's say either sometime in May or maybe even June, give you more time to accurately or more for us to better get the talk marketed. So
Yeah,
it
so
was very interesting. Yeah.
what is the general situation for this one? I think